How do we eliminate parameters from parametric equations? Eliminating a parameter converts parametric equations into plane curve equations. Because we're more used to plane curve equations, this makes them easier to graph. And essentially what I mean by eliminating a parameter is t should not be in our answer. So there should be some equation relating y and x. That would be a plane curve, and we want to get rid of t. So typically what we'll do, especially when one of these is linear, is to solve it for t and then substituting to the other. So y plus 3 equals 6t, and t equals y plus 3 over 6. Now let's substitute that in. X equals 2 times t plus 6, and t was y plus 3 over 6. Now we can solve this for y. Subtract 6 from both sides. The 2 and 6 can be simplified to 3, and then we can multiply by 3 on both sides. So we get 3x minus 18 equals y plus 3, and this is the same as the plane curve, y equals 3x minus 21. So what this is saying is this graph that uses these two parametric equations, the path that it follows is this linear equation. Convert this set of parametric equations to a plane curve. So once again we want to get t by itself in one of these and substitute into the other. Typically it's easier to take the one that has x in it and write it in the other form, get t by itself in the x equation, because typically in plane curves we prefer having y by itself. X to the 1/3 equals t by raising both sides to the 1/3 power, and now we substitute that in. So y equals 3 times the natural log of t. T is x to the 1/3. And now by our exponent rules, we can say that this is 3 times that 1/3 natural logs of x. So in other words, y is the natural log of x. So that's our plane curve. Write x equals 2 plus 5 cosine theta and y equals negative 6 plus 4 sine theta as an equation in the xy plane. Well, whenever we have both of them being sine and cosine, it's actually the easiest way to eliminate both variables is to try to set up one of the trig identities. So something like sine squared plus cosine squared equals 1. So that's what I'm going to do here. It is possible to do it in other ways by, say, getting cosine theta by itself, taking the arc cosine of both sides and substituting that in. But if I solve this for cosine theta, solve this for sine theta, then we can set up an equation in this form. So let's solve this for cosine theta. X minus 2 divided by 5 equals cosine theta. And here, add 6, divide by 4. So substituting this in for cosine squared and this in for sine squared, we get sine squared y plus 6 squared over 16 plus cosine squared, so that's x minus 2 squared over 5 squared is 25 equals 1. And this is our plane curve. You should recognize this plane curve as an ellipse with major axis 10 and minor axis 8. So that's how we can eliminate parameters, either by solving for one variable and substituting in, or by setting up something in terms of an equation that we know is true, like an identity. Thanks.